Hello students. Now we are going to discuss the concept correlation. The definition is given by whenever two variables x and y are so related that an increase in the one is accompanied by an increase or decrease in the other, then the variables are said to be correlated. Means, so this correlation gives the relation between the two variables. Like if there is an increase in the one variable, so there is an increase or decrease in the another. Okay, so the one, these two are related one another. This is the one best example for the correlation. The yield of crop varies with the amount of rainfall. So as you know, the yield of crop depends on the rain falling. Okay, so this, there is a relation between yield of crop and rainfall. This is the, you can consider this as a one variable, and yield of crop is a one variable and the rainfall is the another variable. So there is a relation between these two. Okay, then we have a types of correlation. The first one is a positive correlation. Positive correlation is if an increase or decrease in one variable corresponds to increase or decrease in the other, then the correlation is said to be positive. Means if there is an increase in the one variable, so there is an increase in the other variable also. If there is a decrease in the one variable, so there is a decrease in the other variable also. Okay, so the example is the correlation between weight and height of the person is a positive, because the height of the person increases, the weight also increases. So this is the example for positive correlation. Then the negative correlation is if an increase in one variable, there is a decrease in the other variable. This is a vice versa. Like if there is a decrease in the one variable, so there is an increase in the other variable. So this kind of relation is called negative correlation. The example is the correlation between increase in the price of a commodity, so definitely there is a decrease in its demand. Okay, so this is an example for negative correlation. Now the third one is perfect correlation. The perfect correlation is what? Yes, if two variables vary in such a way that their ratio is always constant, then the correlation is said to be perfect. The increase and decreasing ratio is always same, so then that kind of relation is called perfect correlation. The example is the pressure P and the volume V of a perfect gas given by the relation PV equal to constant. So this is the example for perfect correlation. So there is another one, like if there is no relationship between the two variables, then they are said to be non-correlated, or those are independent. The example is weight of a student and the marks scored by him in the examination are not correlated. So the weight of the student, it is not at all related the marks scoring by him. So these two are independent. Okay, there is no relation between these two. So now the next is the Curl Pearson's coefficient of correlation. So this is what, so in the previous definitions we just saying that the relation between the height and the weight of a person. Okay, positive correlation, negative correlation, that we are saying. Now those relations we are calculating numerically. See, the numerical measure of correlation between two variables x and y is known as Curl Pearson's coefficient of correlation. We are going to calculate the relation between the two variables numerically. Okay, and that coefficient of correlation we denoted by small letter r. Okay, now we are going to discuss how we are finding the coefficient of correlation, that is R. So here in the problem, the set of values of x and y will be given. This is the x1, x2, so on xn. This is the values of x. Then y1, y2, so on y1, yn be the corresponding values of y. Okay, the set of x and y values will be given. Now we are going to find the relation between the values of x and the values of y numerically. Okay, then the coefficient of correlation between x and y is defined by the formula. So this is the formula we have to find the relation, the coefficient of correlation. Okay, then the formula is summation x minus x bar into y minus y bar divided by n into sigma x into sigma y. So there is one, this is simple formula. Using this we find R, where these x bar and y bar are means of x and y and sigma x and sigma y are respectively the standard deviations of x and y. Okay, now by the definition of the standard deviation, we have sigma x equal to square root of summation x minus x bar square divided by n, and summation y equal to square root of summation y minus y bar square divided by n. Now these values we are going to substitute here. When you substitute sigma x and sigma y, so in the denominator of the denominator we get square root of n, and here square root of n. Square root of n into square root of n is n, and this n cancelled. Then in the denominator here, this summation x minus x bar into y minus y bar divided by, this is square root of summation x minus x bar, that is from this term, into, so here it is a square root of summation y minus y bar square. This is the another term. Okay, from this term square root of summation x minus x bar whole square, from this term square root of summation y minus y bar whole square. Now we are taking x minus x bar as a capital X, y minus y bar as a capital Y. Okay, then we write this formula in a very simple form as r equal to summation xy cap divided by square root of summation x square into square root of summation y square. Okay, it becomes very easy to remember the formula, where capital X is x minus x bar and capital Y is y minus y bar. Okay, so this is a very simple formula to find coefficient of correlation. Okay, now the coefficient of correlation always lies between -1 and +1. So this condition you have to remember. Whenever you calculate the value of r, that value of r must lies between -1 and +1. It should not exceed the range. Okay, if r equal to +1 or -1, we say that x and y are perfectly correlated. That is what we call, if r value is +1 or -1, that relation between x and y are perfectly correlated. If the value of r is 0, then there is no relation between x and y. Okay, these conditions you remember. Now we take some problems to find the coefficient of correlation. Yes, so here is one example. The students got the following percentage of marks in economics and statistics. So marks in economics, here it is given. Marks of statistics, okay, given. The one values we take as a x, the other one we take as a y. Now we find mean of x and mean of y. X bar and y bar we find. Okay, x bar is given by summation of x. Summation of x is what? It is a sum of the values of x divided by n. N is the total number of values of x. Okay, the summation of x is 650 divided by n is 10. There are n values of, sorry, 10 values of x. Okay, then it is 65. Then similarly mean of y is given by 66. Now what we have to do, taking the given small values of x and y, now we form capital X. Capital X is what? X minus x bar, small x minus x bar. X minus x bar is 78 minus 65, 13. Then 36 minus 65 minus 29. Like that, all the corresponding values we have to take. We get the values of capital X. Similarly, capital Y is y minus small y minus y bar. Okay, these are the values of y. Then according to the formula, we have summation xy, summation x square and summation y square. We need the summations of these three. So we take the column for capital X square, then we take the column for capital Y square, then we take a column for xy. So we find the values of the sum of the values of x square, y square and xy. Okay, then these summations values we substitute in the formula. The formula is r equal to summation xy divided by square root of summation x square into summation y square. This is summation xy value into square root of summation x square value and summation y square value. Then that on simplification, the value of r is 0.78. So this lies between -1 and +1. Okay, this is the one problem, and this is the another similar problem to similar problem. Now we take the one problem which is little bit different in the sense we use one alternative formula. The formula is, this is the another formula to find the value of r, that is the particularly if in the problem using the formula, particularly if this formula is given and find the value of r, then you can apply. Otherwise, as we discussed in the first problem, so that formula is a very simple to find the value of r. You apply that formula only to find the value of r. If particularly that formula is given means you can apply. Otherwise, no need to apply this formula. I just discuss one problem using this formula. Now, this is the given data x and y. Now, this is sigma x square is given by summation x square divided by n minus summation x by n whole square. Okay. Now, what all we need to find sigma x square? We need x square. Okay. Then we need, for the sigma y square, we need y square. Then in the formula we have x minus y, taking that column and square of that. Okay, so this is x minus y square. Okay, now we take the summation x, summation y, summation x square, summation y square, then summation x minus y and summation x minus y square. So now substitute in the formula. Summation x square divided by n is the total number of values of x, then summation x divided by n value and square of that. So this is the sigma x square value. Similarly, we can find the sigma y square value. Okay, substituting the values, then sigma x minus y the whole square. Okay, then substituting all the values in the formula, we get the value of r. Okay, this is the one alternative formula. Only when using the formula this, then only apply. Otherwise, the first problem what we discussed, applying that, it is a very simple to find the value of r. Okay, thank you.